Hi everyone, welcome to another video, and today we'll be discussing about a new question called median of two sorted arrays. So the question reads as given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The question is straightforward. We'll be given two arrays nums1 and nums2, and both of those arrays are sorted, and then we need to find the median. So if we try to solve it like in an intuitive way, like whatever comes to our mind first, then we just have to merge the two sorted arrays, and then after merging it, then we're gonna find the length, and based on the length we just find the middle, just have to find the middle values. It's simple as that. But that will be like our merging will become OFN operations, right? We're gonna OFM plus N operation because we're gonna iterate both the arrays. Then we compare that, and then we're gonna create our new arrays, new array with the merged number. That will be OFM. That will be a new space of, or space complexity of like OFM plus N. Then the another method is like just create two pointers, like pointer I on the nums array 1 and pointer j at the nums array 2, right? And both pointer will be initiated at 0. Then we're gonna count the length, and based on the length we're gonna find how odd or even and how many elements we need to find to get our median, right? For and after calculating from the length, and we're going to compare the two pointers, we're going to iterate through them, and we're going to find that whichever is like smaller for nums1 of I, then we're going to compare that to nums2 of j, and whatever is minimum we're going to return that, we're going to put that in an array, and we're going to increment that counter, and we're going to do that. Whatever is minimum we find, we're going to keep that in a different array until we reach our count. Once we reach our count, then we just have to return the last value or the average of last two values based on the or even condition, and that's that, right? That too will take OFN operations because we're going to iterate through post case OFN, and that will take space complexity of like OFN by 2, m plus n by 2, I would say, because we have to create an array that will save the numbers until we get the median. Median means the middle value, so that will be like OF m plus n by 2 space. But both of those solutions makes it like an easy or medium kind of solution, right? But what makes it difficult or hard question is like the line that tells us like the overall runtime complexity should be OF log m plus n. That makes it difficult or hard question. So OF log m plus n means it asking us to calculate the median by binary search, right? And it is extremely difficult to do binary search. It's not intuitive enough to do binary search on two different arrays and find out the different edge cases and derive the conditions how to move our mid. Those steps makes it a hard question. But anyway, we're going to solve the binary search question, binary search way, because that's the optimal solution. And let's do that. Okay, then here consider a example where m are nums 1 equals to like 1 1 2 4, and nums2 equals to nums2 equals to Let's do one thing, 4, maybe 3, 6, 7. Okay. So then the total length here will be 3 plus 3, that is 6, right? So where would be the median if, let's add 1 for simplicity for now. Okay, so this will become 3 plus 4, 7. So this will become odd. So where would be our median? Our median will be the, if we sorted it, 1, 2, 3, 4, 6, 7, 8. Median will be 4. 0, 1, 2, 3. The total 7 by 2, that is 3. Right? That is the index we should be getting. So that's that. So let's consider, and here we see that whenever we calculate a median, the number of values to the left and the number of values to the right are same. Okay. Then what are you going to do? We're going to run our binary search on the array that has lesser number, and our goal is to find 4 number or 4 items, or we can say that our goal is to select 4 items from nums1 and nums2 in a sorted way, so that the 4th position should give us our median. And we cannot just select from 1, because you see that 3 is here. The 3 needs to be picked up from nums2 to get the correct answer, that is 4. So we cannot do it, just pick 4 item continuously. We have to conditionally check how the sorted, our array will be stay sorted when we are picking off the items. So that's that. So one clue is here that the number of items to the left and right remains the same. So our goal is just to calculate up to 4 items. So we have to pick 4 items from num1 and num2. And if we successfully picked those items in a sorted way, then we will get our answer. To do that, first we have to run our BS or binary search on nums1 array, because that is the sorted one. So we're going to start index will be 0 and end index, that is L is equal to 0, and end index will be our length, that is 3. We are considering one index more here. Similarly, we can start it from one index below 0, but whenever it is below 0, we have to consider it's minus infinity. When it goes beyond the length, that is length index, like 0, 1, 2. Now because we are considering length, let's say beyond 2, so we have to return infinity. And this will handle some edge cases, so that whenever we consider or comparing the values, if it goes beyond this, the last index or first index, it will return minus infinity and infinity based on in what direction or direction it is going. Now then, if we calculate here mid will be 0 plus 2, or sorry, minus 1 plus 2 is the same thing. Minus 1 plus 3, this is 2, or 0 plus 2 by 2, right? And that will become our 1. So whatever our mid, right? Consider mid as like px, or we can say that partition from partition x, or number of items we are picking of nums1 array. Okay, that is our mid, or we can call it mid. But our simplicity, so that in future we're going to use this value with py, so it will be easy to name the variables. The first one, this is our mid. We can call it px, and it signifies that how many items we're going to pick it from nums1 array. L plus R by 2. Method floor. Okay, so that will give us 1. So 1 item. Let's consider we are picking up, just forgot about this index, not index. Just consider it as a number of items. We can say that only 1 item, or picked up only 1 item. And then what will be the number of items from nums2 array? To find out the index inside nums2 array, we have to consider the whole length, that is m plus n. What is that? 1 2 3 4 5 6 7 plus 1 by 2 is 4. Okay, that is the index. That should be the number of items in nums2. We should be picking like 4, right? So, but we already picked a px at 1 item, right, for px. So how many items we should be picking from py? So number of items for py minus we already picked whatever we already picked. So that is into px. So that will be like 3, right? And now then, so now our px become 1, py become 3. So what it means, from num1 array we picked up 1, and from num2 array we picked up 1 2 3 items. So what remained in num1 array is 2 and 4. What remained on nums2 array is 4 6 7 8. Okay, so now we derived our mid, right? We calculated mid, and we calculated what should be the mid. We can consider it's the mid in py, but the way to calculate it, but in a simpler way to understand it, the first mid is the number of item we are picking up from nums1 and number of item we're picking up from the nums2. Okay, in this particular case we have to check if everything is in sync. Means everything that stays in the right side should be greater than everything that is there in our left side. So we're gonna check if 1 is lesser than 4. So yes, so we are good here. Is 3 greater than 3 smaller than 2? No. So here it is a problem. So then we have to move our pointers, L and R pointers, right? So here our L will become, that is L that were our first L was 0, and R was the length of the first array, right? M. So now because our L1 is now L1 and L1 is perfect, but this one, our L2 or R2, make it like L1, L2, R1, and R2. Okay, the right side, the left side of the nums2 array, right side of the nums2 array, left side of the nums1 array, and right side of the nums2 array. Okay, and then L1, R2, this condition satisfies. L1 is lesser than our R2 first element. This is fine, but the second condition is not satisfying because L2 last element is not smaller than R1 nums1's right side elements, the first element. In that case, we have to move our L equals to px plus 1. So mid plus 1, just like that, right? We have to move it to mid plus 1. So we're going to move our L to 2. It means we are selecting one more item from the nums1. So we're gonna move it like, we're gonna make it like, what's gonna happen now if we move our px to 1? It's gonna happen like 1, 2, right? And then what happened? Then similarly, our py will be getting calculated. Py will now become like less than, like previously it was 3, and now it will become 2, right? It will be only picking 2 items. So here it will become like 3 and 6, 3 and 6, and 4 will go here, and then 7, 8 will go here. And in next iteration, again, this will fail. This will pass, but this will fail, right? If this fails, in the sense our, what is that? This again, our L1, L1, L2, R1, R2. Okay, again the L1 and R1 R2 condition satisfies, but L2 and our R1 condition dissatisfies. So again, we have to move our px to right. Means we're gonna again pick a new element from num1 array. Now what happens if we pick it? Now it will become 1, 2, 4, right? And now, because you're gonna, how many we're gonna pick from nums2 array? Now only 1 we can pick, so you're only gonna pick 1, right? Now nothing left here, so anything we want to pick, it will become infinity. Anywho, in next iteration, what we left here, 6, 7, 8. Now what are we gonna do? Again, we're gonna compare. This satisfies? Yes. Is this satisfies? Yes. 3 is lesser than infinity. 4 is lesser than 6. If this condition satisfies, then our median will be max of these two number. Max of 3 and 4, that is 4. That will be our answer. So this is the logic. The only thing is like we have to remember mid equals to px equals to m by 2, we can say, like, or for the smallest length array, that is first index left plus right by 2. For the smallest, it's a normal calculation, like in every binary search, right? Left index for right index divided by 2. Px, that is our px. Here we can call it like how many items we are picking up from the number 1. Actually, this is mid. Then py will be the mid of both the arrays, and then minus px, because we're going to consider how many items we are picking up from num2. So basically we are saying if it's sorted, what will be the median, what position of the median? This is like m plus n plus 1 divided by 2. That's it. Okay. And then we are saying that, okay, this many items should be picked up from num2, but now we already picked something from px, so we have to subtract that. We only can pick that many items from the num2, so we have to just subtract that from the py. So this is the main thing. Everything else falls in the place after that. So then the step 1 always will be the finding the smallest array. because we'll be running our uh, binary search on the smallest one. So if nums oops if nums1 dot length is smaller than, let's do nums2 dot length is smaller than nums1 dot length, we're gonna swap it. Nums1 nums2 equals to, okay, it will make sure that our nums1 always stays the array with smaller length. Then step 2, let's create variables and assign values. So let m equals to nums1 dot length, let n equals to nums2 dot length, and then because we already made sure that the nums1 length nums1 will be always with the smallest length array, so m will always be the smallest or same, right? If the both array has the similar length or same length, so our m will always be smaller or same, never will be more than n. Anywho, now we have to, in step 3, set the left and right indexes, right, for the binary search. So in that particular way, we're gonna let L equals to -1. Remember, we need to, every time it's going beyond the indexes, we have to just make it, when it become less than 0, we're gonna make it -infinity, and if it's going beyond the length or beyond the last index, we have to make it infinity. So let r equals to, right, m in the sense last index plus 1. And then we have to find our while loop. So step 4, write the binary search conditions, right? So while left less than equals to right, we need to and calc mid, that is px. Okay, so let px equals to math dot floor l plus r divided by 2. So this is like the number of items we are selecting from the nums1 array. So we are, what is it? It's just a mid we calculated, but in this particular solution, we need to consider it's like this is the number of items we selected from the nums1 array. Then we're going to calculate the mid, or a mid of the mid with a combined length, and we have to consider how many and we have to derive how many items we are going to select from nums2. So you're going to make it py and math.floor. It's like m plus n plus 1 divided by 2. Okay, so basically it's saying us how many numbers if we combine an array, right, like m plus n, how many numbers we need to select from the combined array to find our median. For example, it's a odd number array, just divide it by 2 and get the ceiling number, and that's that. And that many numbers we need to get to find out the median. So that is this calculation is that we are deriving if both the arrays are merged, okay, then how many items we need to find to get our median. That is that number. And then we are subtracting px from here to find out, okay, this is from the total number of items. Now we already selected something from the nums1 array. Then how many left? How many we need to select from py? So from py we are subtracting the px. So px, and this will be considered as the items we are selecting from the nums2 array. nums2 array. Okay, simple then. Then we have to write our conditions. And what are those conditions, by the way? Our we have to find our numbers based on our mid, okay, and those numbers are like let L1, let L2, then we're gonna find let R1, let R2. So what is L1 then? L1 is like if we divide our nums1 array at px index, right, with px, what item will be the maximum to the left of that index? That is our L1, right? And similar to like py, if we divide the nums2 array based on py, what will be the max item to the left of py? That's L2. And R2 is like if we divide the nums1 array based on, you know, that px, what will be the max item to the right side, or sorry, to the mean item to the right side of that, you know, that partition. That's how similarly R2 will be the what is the max nums2 array for that py partition. So yeah, so L1 equals to, then now we have to check if what is the value here, like if the index is, because we will be, that virtual line is there, and if we are going below that, or there is a chance that it will become negative, and if it become negative we have to return minus infinity. So we have to consider that here. It will like nums1 of px minus 1, but we need to put a condition here, like if px minus 1 less than 0, no, yeah, let's put greater than equals to 0, then we are fine. We can return it like nums of px minus 1. But if it become less than 0, Then we have to return number dot negative infinity. Yeah, that should do the trick. Similarly, we need to do for our py, that is py minus 1 greater than equals to 0. Then we have to return nums2 py minus 1, if not number negative infinity, if not number dot negative infinity. Perfect. So this will be the left side of the partition we created uh, with px and py. And then what will be the r1? R1 will be like nums1 of px we don't have to make it px p minus, because we already started from -1 here. That will take care of it. Don't have to check -1. We are good. And we need to do it like greater than 0. Perfect. Perfect. Similarly here, we're gonna do like if px smaller than m, return it. And if not, number dot positive infinity. Similarly, we need to do that for py less than n, right? Nums2, and return nums2 of py, then number positive infinity. So this one is our partition we created with px and py. Perfect. Now we need to compare these 4 numbers that we derived. And first condition first, that if L1 is smaller than R2 and L2 smaller than R1, then we get our mid. So if L1 smaller than equals to R2 and L2 smaller than equals to R1, then we get our condition. Also, we need to check our odd length or even length, right? If like m plus n, m plus n mod 2 equals to 0, then return we have to return our math math.max L1 L2. Okay, we have to find right side max number, left side minimum number, and we have to add it, and we have to send the average of it. So max side of the left side, then we have to add the math.mean of right side, that R1 R2, and we have to average it, right? Else return. If it's odd, then just have to return left side max. Simple. Then if our L1 is greater than R2, then we have a problem. Or if our L2 is greater than R1, we have a problem, right? So if our L1 is greater than R2, then we have to move our right pointer, R equals to px minus 1. Else we're moving our right pointer to left. And else we have to move our left pointer to px plus. We are picking one more item from left side. In this case, we are skipping one item from the right side. No, in this case, we are reducing the number of items we picked here. We are reducing the number we picked from our nums1 array. Nums1 array by 1. Here we are like increasing the item we picked from the nums1 array by 1. Perfect. So this should solve our question. Now let's try. Nope. What went wrong? Not a number. Oops. Could be an error. It did not give an error. See? Syntax issue. Logic is fine. Let's run it. Perfect. Now let's try to submit it. The content. Paste it. I'm gonna run it. Everything has ran. Submit. Passed. And that's that. Hope you understand the solution, because definitely I didn't. I solved it long ago using that dumb method like pointer or just merging the arrays. But binary search way was hard, even harder for me to get it. But the thing is, like, the point is that you just have to remember, like, the same thing. If both the array are merged, where will be the median? We have to count that. First of all, we are getting a mid value from the num1 array, and we're considering that much items we picked from num1, and then we calculate how many items should be there in our median by calculating m plus n plus 1 by 2. And we consider that many items we should pick from py, and then we see, okay, we already picked px, how many items then need to be picked from py. So we are subtracting that from that new median that is we calculated from whole length, that two items. Everything else is, after that, everything else is straightforward. We consider that px and py as a virtual line. Px is a virtual line from for the num1 array, and we calculate left and right to that line. And we consider py as a virtual line for nums2 array, and we calculate left and right from that line, and we compare those values, because the condition is everything that is in left side should be lesser than everything that is right side. Keeping that in mind, we consider those two values, and based on that we move our pointers. Pointers are moving just by one. For example, if our L1 is larger than R2, it means we have to drop that item from the left. So we are moving our pointer 1 or mid pointer by 1 to the left, means we are dropping one item from the num1 array. Similarly, if our L2 L2 is like greater than R2, it means we are picking one more item for px. So we are increasing px by simple as that. So that's that. Thank you for watching, and let's see you in our next